In the last video, we talked about the concept of scientific law, and I tried to make it clear that in science, we never use the word law to mean that it's something that's set in stone, that will never change, something that's universal and that there's never exceptions. On the contrary, every single example of a scientific law that you can think of, there's probably an exception for it out there. And there are many examples of scientific laws that have been changed or revamped throughout the history of science. So we don't think of a scientific law as something that's set in stone. On the contrary, we think of something that could be changed, and we also don't think of it as something that's universal and works in every case. Therefore, we don't use the word law as something that's a fact and it's going to last forever. We use scientific law as something that's defended so much by the data that we are currently, under the current knowledge of science, saying that that's the best way to describe that relationship, that phenomenon. Almost like a hypothesis that's been so consistently tested and defended by the data that now it's part of a working knowledge or of a theory, and that's why theory sometimes includes laws or statements of science. But these are not statements that can't be changed. They're just statements that have been incredibly defended by the data and now are part of a working theory, almost like things that used to be hypotheses or predictions but now are so well tested that we say this is the best current way to describe this event, and it's the rules by which nature follows, seems to follow, and do these things. But there are two other words which are sometimes used in the context of science which have similar meaning, and I wanted to clarify that so that you don't get confused. These are principles and postulates. And I'll start with postulates because it's a little easier to understand. A postulate is like a logical assumption that you don't necessarily have to prove. So it's different from a law in that sense. Remember, a law may have been at one point a hypothesis that you had to prove, and then eventually you tested and retested so much that now you say that this is like how it pretty much seems to work in retro life. But a postulate doesn't need to be proven. It's a self-evident statement. It's something that's like logically right, and that, there's no need to seek out proof. Now, of course, logic can be misinterpreted, and in the future you can maybe reevaluate what you think of this postulate. But what I mean by that is that statement that it's used in science to describe something that you don't really need to set out to prove it. It is self-evident. The best way to look at it is to see an example. So when you say it's possible to draw a straight line from any one point to another. So you see, that's just a definition almost. So by definition, you're defining what a line is, which is a connection between 2 points. So there's no need to prove that. That's just self-evident because it's a definition that you created. Another example would be light comes from a source. You couldn't possibly have light that comes out of nowhere because it would have to start somewhere. So that's a statement that does not need to be proven, right? So that's basically what a postulate is. It's something that sounds like a law. It's a statement that describes something, but it doesn't need to be proven. It's self-evident. It's like a definition. Then there's also the concept of principles. Now, if you pick up a dictionary, it gets really confusing because it says it's a rule, so it sounds like a law, that must be followed, that is usually followed, or that can be chosen to be followed. And it's also described as the inevitable consequence of something. And so what is this really? And in society we use the word principles like your moral principles, the rules or behavior that you follow, that kind of stuff. Or basically if this happens, that inevitably happens after. So that's like the principle of the thing, Basically that's the idea of a principle. But how do we use that in science? In science, we think of it exactly the same way. It's either a rule of conduct or a fact of nature or some descriptive or fundamental law. So it can be used in any of these senses. So let me give you examples. The scientific method is a principle or a rule of conduct by which scientists perform their experiments, go about knowing more about the world. So in that sense, the scientific method is a principle of science. Do you see that? It's the rule of conduct of science. Fact of nature, which is used as a principle, for example, is birds are alive. So see, that is based on a set of postulates which define what life is. You now can say a principle of science, a fact of nature that's based on a series of postulates or a series of definitions. Now, you can't really argue against it because it's based on postulates. It's based on definitions that don't really need to be proven. You set those definitions up on stone. You can always change them if that's what you want, but If they're going to be the truth, then you can't argue against the fact of nature. But it's not necessarily something that's based on evidence, although of course there is evidence that birds are alive. But it's a self-evident fact almost, right? It also can be used in the sense of a descriptive or fundamental law. For example, the speed of light is the ultimate speed limit of the universe. So that's a principle in physics, right? You could also say that's being basically used interchangeably with the idea of a law, of a scientific law. So sometimes principles are used to mean the same thing as a scientific law. Sometimes they're used to mean like the rule of conduct or the procedures to do something. Or sometimes they're like statements of facts, which basically sound like a postulate, right? So understand that that's how we use the word principles and how we use the word postulates, but that's different from the concept of a scientific law. I hope that makes it a little clear and you can kind of understand what I'm talking about there.